All right, let's talk muscle fatigue. Ready? Standards and objectives, pause it, peruse it. Okay, a relaxed skeletal muscle. So remember, a muscle fiber is a muscle cell, and when it's relaxed, the demand for ATP or energy is low. There's plenty of oxygen for the mitochondria to produce ATP through an aerobic process, meaning it needs oxygen. Plenty of resources. And oxygen can diffuse slowly into the muscle. There's no great demand. When there's enough oxygen, we carry out cellular respiration, the aerobic version. Plenty of oxygen, easy peasy. Now, when there's moderate activity in the skeletal muscle, the muscle fiber or cell demand for ATP or energy increases. So more oxygen is being used by the mitochondria to make ATP. Our respiration rate is going to increase to bring more oxygen. The oxygen diffuses faster into the muscle cells, but the body is in general still able to keep up. When we get to peak activity in the skeletal muscle, the muscle fiber or cell demand for ATP or energy increases even more. More and more oxygen is being used by mitochondria to make ATP. And although the respiration rate is increasing, it simply cannot keep up to bring enough oxygen. So the mitochondria are not able to consistently produce ATP because there's simply not enough oxygen. Again, the oxygen cannot diffuse fast enough to meet the demand. So what happens is we switch to anaerobic respiration. So since the muscle fibers are not getting enough oxygen to meet the demand for ATP, the cells switch to an anaerobic process called glycolysis. And glycolysis is anaerobic, meaning it doesn't need oxygen. Now, it still produces ATP, just not as much. Now, here's kind of the downside. Glycolysis also, it doesn't produce as much ATP, but also it produces something called lactic acid. And when lactic acid builds up, muscle fibers cannot continue. Fatigue. So muscle fatigue means a decline in muscle force over time. You can see the muscles less and less able to contract over time. When does a skeletal muscle get fatigued? Well, when it can no longer contract, even though it's being stimulated to contract. So the message is coming through contract, 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 and the skeletal muscle is like, I can't do it. It's fatigue. So what causes that muscle fatigue? Well, it can be a buildup of lactic acid. So remember, if there's a quick high demand for ATP, like if you're sprinting, run out really fast. Or if there's an exhaustion of energy reserves. So we have sustained muscle contractions for long periods of time, like running a marathon. So either lactic acid builds up or our energy reserves are used up. How do muscles recover then? Well, we remove the lactic acid, our energy reserves are replaced, and the heat that's generated by muscle activity is removed. So we sweat, our blood vessels dilate, that's vasodilation, to get rid of the excess heat. How can you reduce muscle fatigue? Well, you can hydrate, drink water. Lactic acid is water soluble, so if you're well hydrated, we can clear it out faster. That's a plus. Breathe deeply. So in through your nose, out through your mouth. It brings in more oxygen and it helps to stop lactic acid from being produced. If the muscles are being stimulated too quickly, obviously that won't matter, but breathing deeply will help. Monitor your heart rate. So keep your heart rate in the appropriate range. So there's a maximum heart rate. So you take 220 and you subtract your 8. That's the maximum. And you have a maximum heart rate range for cardio activity, and it should be 65 to 85% of your maximum. So here's an example. If you were 40 years old, you would take 220 minus 40, 180 is the absolute maximum heart rate. But for your cardio range, 65% of that is 117 and 85% of that is 153. So when you're in cardio, your heart rate should be between 117 and 153. If it is below 117, you need to work a little harder to bring it up. If it is creeping above 150, you need to slow down to bring it back down. And you can see that for the fat burning zone, if you want to burn fat, you need to have your heart rate even less. Okay, but for cardio activity, that's how you calculate your appropriate range. Be cautious lifting weights. So lifting weights requires more oxygen. So we want to make sure that when we're increasing repetitions and increasing weight amounts, we do that gradually. If you feel a burn, decrease your intensity. That burn is a defense mechanism that's like, hey, slow down, ease up, to help prevent overexertion. So slow down, lower the weight, okay? So lower your speed, decrease the weight, decrease the number of repetitions. Stretch before and after your workout. It helps the muscles warm up. It helps release lactic acid, super important. So warm up, cool down. Eat a balanced diet. So things like magnesium and fatty acids and B vitamins, among a whole list of other things, are important for healthy muscle function. Calcium, vitamin D. There's a long list, but here are some ways that you can get these vitamins. Work out frequently. So if you're more physically fit, your body gets more efficient. So you end up burning less glucose. Less lactic acid will build up. So working out frequently, having a regular routine is important. But you should also alternate exercises. So it gives your body time for repair. There's less risk of injury. So you can see this sample schedule, cardio on one day, then you do upper body, then cardio, then lower body, then cardio, then upper body, then there's a rest day. Alternating activities is important. Rest is so important. So taking rest days, it's not just an idea. It helps restock glycogen, your energy storage. It reduces risk of injury. Rest days are important. And it allows your body to repair. We're going to be doing in class some muscle fatigue experiments, so get ready. All right, in class we'll play a blue kit, but that's it. That's muscle fatigue. I hope you learned something new today.